There is a question that has been sitting at the center of philosophy, neuroscience, and linguistics for centuries, and it is one of those questions that seems simple until you actually try to answer it. You open your mouth to respond and then realize, wait, to answer this, I need to think about thinking itself. And the moment you do that, something strange happens. You start wondering whether the thought you are having right now would exist at all if you did not have the words to think it in. The question is this: what came first, thought or language? Did humans develop the ability to think complex thoughts and then invent language to communicate them? Or did language come first, and did having words and grammar and structure actually create the kinds of thoughts we now consider distinctly human? Is language a tool that thought uses? Or is language the thing that makes certain kinds of thought possible in the first place? This is not a question with a clean answer sitting at the end of it. It is a question that pulls apart as you examine it, revealing layers underneath layers. And the answers researchers have found, from studying human infants, from studying animals, from studying people who lose language through brain injury, from studying how different languages shape the minds of the people who speak them, are some of the most genuinely fascinating findings in all of cognitive science. So let us think about thinking and try to figure out what was there before the words. Subscribe to Freud Mind for more of this. Now, let us get into it. Start with the most basic version of the question, because it is actually the easiest one to answer with some confidence. Did thought exist before language? Historically, in the story of the human species, yes. Unambiguously, yes. Modern humans, Homo sapiens, have existed for somewhere around 300,000 years. The earliest evidence of complex symbolic language, of structured communication systems that resemble what we would recognize as language, appears in the archaeological record somewhere between 50,000 and 100,000 years ago, at the most generous estimates. That leaves a gap of at minimum 200,000 years, and possibly considerably more, during which anatomically modern humans were walking around, making decisions, solving problems, building things, navigating social relationships, and doing the countless things that require some form of mental processing, without anything resembling the kind of language we use today. Before that, you have the broader genus Homo, human ancestors going back millions of years. Homo erectus, who used fire, made standardized tools, and appears to have had some form of social organization, existed roughly 2 million years ago. The capacity for thought, for planning, for problem-solving, for social reasoning, clearly predates language by an enormous margin in evolutionary time. So, at the species level, thought came first. Thought existed without language for an extraordinarily long time. The brain was solving problems, navigating environments, and managing social dynamics long before anything resembling grammar or vocabulary was present. But this is where the question gets more interesting. Because the fact that thought preceded language does not mean language did not change thought. It does not mean that the kind of thinking humans do today, the abstract reasoning, the hypothetical scenarios, the ability to think about things that do not exist or events that have not happened yet, would be possible without language. It might not be. And that is where the story becomes genuinely complex. The clearest window into thought without language in humans is infancy. Babies are, for the first months of their lives, thinking creatures with essentially no language at all. And what researchers have found by studying infant cognition is that thought, sophisticated, structured, genuinely complex thought, is happening before a single word is understood or produced. Infants as young as 5 months demonstrate object permanence, the understanding that an object continues to exist even when it is out of sight. This sounds basic, but it requires the brain to maintain a mental model of something that is not currently being perceived. The object is not there. The infant knows it still exists. That is a form of conceptual representation, a thought about something absent, occurring without any language whatsoever. Infants demonstrate numerical reasoning before language. Studies show that babies as young as 6 months can distinguish between groups of different quantities. They look longer at unexpected numerical outcomes, suggesting they have some form of expectation about number. They are doing something that resembles basic arithmetic in a pre-linguistic brain. Infants understand causality. They understand that objects are connected in the physical world, that one thing moving into another causes it to move. They have expectations about physics, about the behavior of solid objects, about the continuity of surfaces that are clearly represented mentally before any language exists to describe them. What this tells us is that there is a layer of thought, a foundational layer of conceptual representation, of models of the world, of expectations and predictions, that does not require language. It is pre-linguistic in the most literal sense. It exists in brains that have not yet acquired language, and it appears to be the cognitive foundation that language gets built on top of, rather than the other way around. But here is the thing. That foundational layer of thought is also limited in specific ways. The infant cannot think about last Tuesday, because without language, there is no framework for representing time as a structured sequence of named intervals. The infant cannot reason about a hypothetical future scenario that has never been encountered, because hypothetical reasoning appears to require something very close to linguistic structure, the ability to build sentences about things that are not real. The infant cannot hold an argument in mind, track its premises, evaluate its logic, because argument structure maps directly onto the structure of language. So thought came before language. But language unlocked levels of thought that were not accessible before. Animals give us another window into thought without language, and the findings are striking enough to challenge some deep assumptions about what the human mind uniquely does. Chimpanzees have demonstrated planning behavior that requires holding a future goal in mind and taking sequential steps toward it. A chimp that hides stones in the morning to use as projectiles later in the day is not responding to an immediate stimulus. It is representing a future situation, planning for it, and taking action in the present based on that representation. That is thought. Complex, future-oriented, sequential thought, without language. Crows and ravens, whose brains look nothing like mammalian brains and share no recent common ancestor with humans, demonstrate problem-solving abilities that researchers find genuinely remarkable. New Caledonian crows can use tools, make tools, and in experimental settings have demonstrated the ability to solve multi-step problems that require understanding cause and effect across several stages. They do this without language, using what appears to be a form of reasoning that involves mental modeling of physical causation. Elephants demonstrate self-awareness. They recognize themselves in mirrors, a test that requires having a model of oneself as a distinct entity in the world. Dolphins communicate in complex ways and demonstrate understanding of syntax in simplified artificial language systems, suggesting they can process the difference between bring the ball to the hoop and bring the hoop to the ball, a grammatical distinction that requires tracking relational structure. None of these animals have language in anything like the human sense. All of them are clearly thinking. They are planning, reasoning, modeling, representing the world and themselves within it, which tells us that a very large portion of what we might call thought, including some sophisticated and impressive portions, does not require language. But here is the boundary. None of these animals write philosophy. None of them build cumulative science across generations, each generation adding to the knowledge of the previous one. None of them develop legal systems or mathematics, or argue about what might have happened before the universe existed. The specific kinds of thought that characterize human civilization, the abstract, the cumulative, the hypothetical, the self-referential, appear to be either dependent on language or at minimum dramatically amplified by it in ways that produce qualitatively different outcomes. Language did something to human thought that goes beyond giving it a means of expression. It gave thought a new medium to operate in, and that medium changed what thought could do. Consider what language actually provides, structurally. It provides a system of discrete units, words, that can be combined according to rules, grammar, to produce a theoretically infinite number of distinct meanings. The combinatorial power of language is staggering. With a vocabulary of even a few thousand words and the rules of grammar, you can produce sentences that have never been said before and communicate ideas that have never existed before. You can describe things that do not exist. You can discuss the past and the future. You can make conditional statements, if this, then that, which are the building blocks of logical reasoning. Before language, thought was constrained by the immediate and the concrete. You could think about what was in front of you. You could think about things you had directly experienced. You could plan a few steps into a future you had some model for. But the kind of thought that says, what if the world works differently than we currently believe? Let me construct an alternative model and examine its implications. That requires the ability to build and manipulate representations of non-existent realities. And language is precisely the tool that allows this. Researchers studying the cognitive consequences of language, what happens to thinking when language is disrupted, have found that certain types of thought are genuinely impaired when linguistic capacity is damaged. People who lose language through stroke or brain injury often retain remarkable cognitive abilities. They can navigate spaces, recognize faces, solve practical problems, play music, draw. But they struggle with certain kinds of reasoning that appear to require holding structured representations in mind. The ability to track the logic of an argument, the ability to do precise arithmetic with large numbers, the ability to reason carefully about time. This suggests that language is not just a communication tool, layered on top of thought that exists independently. For certain kinds of thought, language is the scaffolding that makes the thought possible. Remove the scaffolding, and the thought cannot be built. The acceleration of civilization through language is one of the most consequential facts in human history. And it is worth being specific about why language had this effect, rather than just asserting it. Before language, or with only the most rudimentary forms of it, knowledge was individual. What you learned through direct experience. You could share some of it through demonstration, through observation, but the bandwidth was limited and the precision was low. When you died, most of what you had learned died with you. Each generation started close to where the previous one had started. Language changed this entirely. With language, knowledge could be encoded, transmitted, accumulated. One person's lifetime of observations about which plants were safe to eat, which hunting strategies worked in different conditions, which social arrangements produced more or less conflict. All of this could be passed on with enough precision that the next generation did not need to rediscover it. They could start from where the previous generation ended. And then writing extended this further in a way that is almost impossible to overstate. Writing made knowledge persistent, not just transmissible within a lifetime, not just passable from parent to child, but storable across centuries and millennia. The accumulated knowledge of every civilization that developed writing became available to every subsequent civilization that could read it. Science, the systematic accumulation of knowledge across generations, is directly dependent on this capacity. Mathematics is directly dependent on this capacity. Every field of human knowledge that has produced genuine understanding of the world is built on the language-enabled ability to accumulate and transmit knowledge across time. Without language, and particularly without written language, human civilization as it currently exists would not be possible. Not because the thoughts would not be there, but because the mechanism for building on them collectively across generations would not exist. Now here is where the story takes its most philosophically loaded turn. Not just that language accelerated thought or unlocked certain kinds of thought, but that language may actually shape what reality looks like to the people who use it. The idea that language shapes thought, not just expresses it, but actually influences how the mind perceives and categorizes the world, is associated with a framework called linguistic relativity, sometimes called the Sapir-Whorf hypothesis. In its strong form, the idea that language determines thought, that you literally cannot think things your language does not have words for, it is now largely rejected by researchers. But in its weaker form, that language influences certain aspects of perception, categorization, and reasoning, it has accumulated a significant and genuinely compelling body of evidence. Color perception is the most studied example. Languages divide the color spectrum differently. Russian, for instance, has two separate basic terms for what English speakers call blue, one for darker blues and one for lighter blues, where English uses a single word with modifiers. Russian speakers are faster at distinguishing colors that fall on opposite sides of their linguistic boundary than colors on the same side. The language is not determining what they can see. Both Russian and English speakers have identical visual systems, but the language appears to be influencing how quickly and automatically certain distinctions are processed. The category exists in the brain, reinforced by the language, and it affects cognition. Languages differ in how they encode spatial relationships. Some languages use absolute directions, north, south, east, west, rather than relative ones like left and right. Speakers of these languages maintain a continuous awareness of cardinal direction, an automatic spatial orientation that speakers of languages like English do not appear to have in the same form. The language is shaping how the spatial world is mentally organized. Languages differ in how they encode time. Mandarin speakers are more likely to use vertical metaphors for time. Earlier events are up, later events are down, while English speakers predominantly use horizontal metaphors. Studies find that this linguistic difference affects performance on certain temporal reasoning tasks. The metaphor structure of the language is influencing how time is mentally represented. These are not dramatic, philosophy-overturning findings. They do not prove that speakers of different languages live in entirely different realities. But they do suggest that the language you acquire in childhood, the specific system of categories, metaphors, and structures it provides, shapes the cognitive tools you have available. Different languages provide slightly different cognitive tools, and different cognitive tools produce slightly different experiences of the same world. Which brings us back to the original question, and to the place where it gets genuinely difficult to resolve. The evidence suggests that thought preceded language, that there is a foundational layer of cognition that operates without words, and that exists in infants, in animals, and in some form in people who have lost language through injury. This layer involves object permanence, causality, spatial reasoning, social understanding, basic categorization. It is real, it is sophisticated, and it does not require language. But the evidence also suggests that language did something to thought that made it qualitatively different. It provided a combinatorial system for building representations of things that do not exist. It provided the scaffolding for abstract, hypothetical, and logical reasoning. It provided the mechanism for accumulating knowledge across generations and building civilization. And it appears to influence, at least in subtle ways, how different aspects of reality are perceived and categorized by different minds. So the honest answer is that it is both, in different senses. Thought came first in evolutionary time and in individual development. But language transformed thought into something that looks, in many respects, almost like a different thing altogether. The thought that exists with language is not just the thought that existed before language, now equipped with a communication tool. It is expanded, restructured, made capable of things that were not possible before, and subtly shaped by the specific linguistic system the thinker inhabits. And here is the question that is worth sitting with after this video ends. The thought you are having right now, the one processing this idea, turning it over, examining it, is it happening in words? Can you find the thought underneath the words, or does peeling away the words just reveal more words? And if you cannot find the thought beneath the language, what does that tell you about which one is actually in charge? Subscribe to Freud Mind for more.